Hello there! How are you? Now, let's consider these two given functions with rational expressions. We have f of x is equal to x plus 1 all over x minus 1, and we have g of x being 1 over x. And we are going to use these two functions and see what will happen if we are going to solve for composite functions. Let's start with this notation. Let's have f of g of x. When we say f of g of x, we are going to change or substitute g of x as the x of f of x. Let me have it like this. We have f of g of x. So all the variables x in the function f of x will be changed to the value of g of x there. Well, let's do it like this. Supposedly, our original, let me have it here at the bottom. Our original f of x function is x plus 1 all over x minus 1. Again, this should be x. This is x. This is our original f of x function, x plus 1 and x minus 1. However, this x's here for f of x function will be changed to g of x. And this is how we'll do it. The g of x is 1 over x. So we'll have it here 1 over x and then 1 over x here as well. So again, you have 1 over x, this is your original x earlier, plus 1. And then you have 1 over x, this is your original x earlier, minus 1. Then, we are going to simplify this. How? By considering how rational expressions work. Let's try to come up with one or singular rational expression for our numerator. Okay? We will treat them using LCD. This is only for the numerator, okay? Because this is all over 1, right? So, their LCD is x. X divided by x is 1 times 1. You have 1 here. You may need to review your rational expressions for examples like this. X divided by 1 is x times 1. You have here x here. And then you will have plus in this manner because plus is the operation in the numerator. Again, this is just for your numerator by LCD and the correct processes. Now for our denominator, the LCD is still x because this is 1 over 1, right? We have here x as well. Let me make it longer. X divided by x is x times 1. You will have here 1. X divided by 1 is x times 1. You will have here x. And you will have here minus, as this is actually the operation separating them. Now, we can use cancellation law here. We could cancel this and that here because the denominator of the rational expressions in your numerator and denominator are the same. Or if you are not, or if you are confused with that, let's try to continue it here. This is fraction here, division. This actually can be transformed using the keep, change, flip method. Okay, we're going to keep the numerator, keep 1 plus x over x. Instead of division, we'll have multiplication and flip this. Because this is division of two rational expressions, or in other sense, division of two fractions. So division of two fractions, division of two rational expressions, keep, change, and flip this. You have x over 1 minus x. And this is the reason why I mentioned earlier, we can cancel that and here, because we have x here and x there, but we cannot do this, okay? We cannot do that. Nor we cannot do 1 and 1 because they are both binomial expressions. In short, the result of f of g of x following the concept of rational expressions and their operations and the process for simplifying it is 1 plus x over 1 minus x. Or you can rewrite the numerator as x plus 1, but you cannot write the denominator as x minus 1 because subtraction is not commutative. This is not the same as the original f of x. Your numerator may be, because you can rearrange it, but your denominator cannot be. Now let's proceed to the second. We have g of f of x. In this case, it's the g of x that we are concerned now, and originally our g of x is 1. Let me write here the equivalent notation. This is actually g over f of x. This means that instead of x for g of x, we're going to use the f of x function. So originally our g of x is 1 over x. That's the original form. But here, we will be changing this to the expression of f of x. And your f of x is also a rational expression, x plus 1 over x minus 1. So you are dividing this 1 over that. Let's do the keep, change, flip method here as well. So this is our numerator. We're going to keep that, change the operation to multiplication, and flip this. You have x minus 1 over x plus 1. And since this is just 1 or 1 over 1, your result is just the same as x minus 1 over x plus 1. So this is the result for our g of f of x. We again use the concepts for rational expressions, and please do not forget them, especially for functions like this, and we're able to simplify them with these processes. That's all for today. You're dismissed, and please do not forget to subscribe now.